All right, welcome to class, everybody. So we're getting close to the end of Unit 2. Just a reminder that next Friday will be our Exam 2 review, and you can take the test on Friday, or you can wait until after spring break and take it the Monday and Tuesday after that. So our lesson today is section 3.5, because we didn't finish all of chapter 3 in the first unit, because this stuff relates more to what we're moving into after spring break. So section 3.5 is about functions and relations, and this homework is super, super easy. I think you guys will finish it really quickly. But the basic idea is that a relation is a rule of correspondence that pairs each element in the domain with one or more elements in the codomain. And you can think about them as ordered pairs. So say, for example, we had a domain, and in the domain, we have the numbers, I don't know, 1, 2, and 3. And then in the codomain, let's say we have like all of the real numbers. So the entire number line is in there. A relation is something that maps something in the domain to the codomain. So, well, actually, let's be more specific with the codomain. Let's say there's like 12 and 8 and 4 or something like that. So a relation would basically be a list of ordered pairs. So I could match 1 to 12. I could put that in my relation. Then I could do 1 to 8 or 2 to 4 and 3 to 8 or something like that. So this would be an example of a relation because I'm matching numbers from the from the domain to the codomain. And the domain of a relation is the set of all of the first coordinates. So this is the domain. And the range is all of the second coordinates that we use. So in this case, the codomain and the range would be the same. But if I had another number in here like a 9, and the 9 didn't show up in the relation, then the range would just be the numbers 12, 8, and 4. Does that make sense? So the important thing about a relation is that every element in the domain has to be matched to something. So if I deleted this ordered pair, that would not be a relation because the 3 doesn't get matched to anything. And a function is a special type of relation. So moving on to the next slide, a function is a relation that pairs each element in the domain with exactly one element of the codomain. So if we go back to this one, this would not be a function because the number 1 is matched to a 12 and to an 8. And so that would make it not a function because functions are special types of relations where each domain element goes to exactly one codomain. So I like to think about functions as kind of being like a machine where you input something into the machine and it does something to it. So like put in the number 1 and maybe it adds 5 to it and it gives you an output. But the important thing about a function is that whatever you put in, it has to consistently give the same output. So in this example of a non-function, the reason this isn't a function is because if I input a 1, sometimes I get out a 12 and sometimes I get out an 8. It's not consistent and you don't always get the same thing out. Any questions about the definition of a function? Okay. So let's talk about function notation. So an example of a function might be if I input a 1, I get out a 6. If I input a 2, I get out a 7. If I input a 5, I get out a 10. If I input a 6, I get out an 11. From the ordered pairs I've given you so far, can you tell what my function rule is? Yeah. Yep, exactly. Because whatever I input into the function, the output of the function is that number plus 5. So the way that we would write that is f of x equals x plus 5. So in this case, x is the input, and then f of x is the output. So one common misconception that people have about function notation is that you're multiplying these two together. That's not what this means. What this means is that you have the function f being applied to the number x, and the output of the function f when you input an x equals whatever x was plus 5. Does that make sense? So, and this number or this letter can be other things, like sometimes they'll use G of X or H of X or things like that. But basically it just means you're applying the function to an input of X. So let's talk about some different functions. So if I had the function f of X equals X squared, if I input a 4, what is my output? 16. If I input a 1, what is my output? If I input a 2, what's my output? If I input a -2, what's my output? If I input a -3, what's my output? 9. So we could graph all of these, and technically I could input any number, right? Like I could input 1.78, square it, figure out what the number is, and that would give me an output. And this is an example of a function because whatever I put into the function, I will be guaranteed to get a singular output. You know, like I input a 1 and I got a 1. It's not like I put in a 1 and sometimes I get a 2, but sometimes I get a 1. I always got a consistent output based on this function rule. And we could graph these points as well to see what the function looks like. So if I go 4, 16 is going to be up here off the graph. 1, 1 would be here. 2, 4 would be here. -2, 4 would be right there. And -3 would be, 9 would be right here. What if I input a 0? Yep, again, output of 0. And this graph ends up looking like this. This is called a parabola, and we'll talk more about them later. But basically, this graph represents the function f of X equals X squared. And sometimes we will replace the f of X with the y because it's graphed on the y-axis. And sometimes if we have a y, we'll replace it with an f of X. So oftentimes y's and f of x's will be exchanged for each other. So there's this trick that you can use if you have the graph of a relation to determine whether or not the relation is a function or not. So we've already determined that this is a function because whatever input you put in, so the x-axis is our input axis, whatever number we put in to the function, it will give us a single output. This is not a function though, because on this one, if this is our input axis, because x always represents the input, if I input, say, I don't know, let's say a 1. If I input a 1, according to this graph, my output could either be a +1 or a -1. And so this equation is not a function. This is just a relation. So it still it still has solutions and all of those kind of things, but it's not considered a function because the input is matched to 2 different outputs. Any questions about that? Okay, so one really quick way you can test this is by drawing vertical lines along the graph. And if there's any place where you draw a vertical line and it crosses the graph twice, that means it's not a function. So like in this case, since it crossed the line twice here, that makes it not a function. But here, you could draw any vertical line anywhere on the graph and it would only cross it once, and that makes it a function. Any questions on that? Okay, let's do a check-in. Scale of 1 to 5. How are you guys feeling about functions versus relations? Okay. So let's practice some. Is this graph a function or not a function? Give me thumbs up if you think it is, thumbs down if you think it's not. Okay, yep, this is a function because wherever I draw a vertical line, sorry, those aren't very straight, but if I draw a vertical line, it only crosses the graph once, regardless of where I draw it. And so that makes it a function. Okay, what about this one? Function or not a function? Yep, this would not be a function. It is a relation. This is actually the equation for a circle, but it is not a function. So we would say, no, not a function. Okay, what about this one? Function or not a function? Yep, nice job. That would be a function. What about this one? Yep, not a function. Okay, what about this one? So on this one, we don't have like a smooth curve that has an infinite number of points. We just have 8 points. But is this a function or not a function? Okay, I'm seeing some thumbs down. Why is it not a function? Which one is causing the issue? Yeah. Yeah. Yep, exactly. So if we draw a vertical line right there, this is saying that an input of 5 has an output of 2 or 4, but it's not consistent. Like sometimes you might get 2, sometimes you might get a 4. And so that makes this one not a function. And on your homework, you'll have some problems like this, where you'll be given the relation like this, and then you'll be asked, is it a function or is it not? And they won't necessarily give you the graph. So if you wanted to, you could graph all these points and do the vertical line test, or you could look at what the vertical line test is really saying, and you could say, well, a vertical line is looking at all of the inputs that are the same, because everything along this vertical line has an input of 5. And if I have 2 points that have an input of 5 that are different, that makes it not a function. And so if I look at this list, this ordered pair and this ordered pair are telling me that an input of 5 gives me a 4, but sometimes a 2. And that is what makes it not a function. Okay, what about this one? Is this a function or not a function? Yep, because no matter where I draw my vertical line, it only goes through a single point. And we can also look at these ordered pairs and we can say every single input goes to exactly one output. There's no double outputs where they go to different things. Now, in this case, they all happen to go to the same thing, and that's fine. That's still a function, as long as every input only goes to one output. Let's see. So to look at some of your homework questions, most of your homework questions have to do with defining the domain and the range. So the domain is basically a list of the the domain is a list of all of the possible inputs for the function. The range is a list of all the possible outputs for the function, which are the points along the y-axis. So in this one, we have a pretty small relation, and the domain of this relation would be 6, 9, 1, and 8. Because those are all of the numbers that you can input into the relation. And then the range would be 9, 4, 1, and 8. And you can put them in any order because it's basically just a list of all the numbers, but I usually list them in the order they gave it to me. And so this would be the domain and range. And then you're asked if this relation is a function. So the thing you do is you look through and you say, well, does 6 go to anything but 9? And as I look through it, there's no other 6 inputs. And I go through every input and make sure there's no duplicate inputs that are going to different things. So in this case, it would be a function. But if you were given something like this one, you would list out the domain. Actually, let's go ahead and do that. So in this case, the domain would be 8, 5, 2, and then if the number is already in there, you don't have to list it again. And then 7, 1, 3, and 4. And then the range would be 1, 4, 3, 2, etc. All of those things. But then you would say that it was not a function because this input goes to 2 different outputs. Yeah. Mm-hmm. Yep. So something like this one would be allowed. This is just fine. So in this case, they all go to the same output. That's totally fine because it still passes the vertical line test. It just wouldn't work if it was the other way. Yeah. All right, so you'll have some problems like this where you have a relation like that they give you. And then you'll have some where they give you a graph, which basically represents an infinite number of ordered pairs. And so on these ones, you're going to be using interval notation because you don't want to have to list out the infinitely many numbers that you could input into the function. So on this one, you would say, okay, well, this graph keeps on going forever in both directions. So remember that the x-axis represents your inputs. So what's the smallest number you could input? Or is there a smallest number? Yeah. Yeah, so for what we have here, it's at -3, but this line keeps going. And if it goes on forever, then you could take any number all the way to -infinity and plug it in, right? Like, because this is just showing part of the graph. And then the biggest number that you could plug in would be anything to positive infinity. So the way that we would write the domain here is we would say that it's from -infinity up to positive infinity. And you use the same interval notation that we used when we worked with inequalities. And you say, basically my domain or my inputs to my function is anything from -infinity to infinity. Then for my range, I say, what is the lowest number that I could get on my output? Yep, in this case, it would be -3 because that's the lowest part on the graph that's on the y-axis. And it can equal -3, so I'll put a square bracket around it. And then what's the biggest number that you could get as an output? Yep, infinity. And that would be a round bracket because you can't plug in infinity. So this would be the domain, this would be the range. And is this graph a function? Yep, because if you do the vertical line test and you draw vertical lines anywhere along the graph, it will only cross the graph once. And so it would be a function. So you'll have some problems like that. You also will have a problem like this, where the graph doesn't go on forever. So there's this key sentence that it says, assume the entire function is shown. And so in this case, your domain would be everything from -2 up to 2. And your range would be everything from -3 up to 1. So if you don't have a function that goes on forever, you may have a domain and range that doesn't go to infinity. There's still an infinite number of numbers between here because there's like -2, -1.9, -1.8, and all the decimals in between. But your bounds would be finite. Oh, on this one, so on this one, you're asked to actually graph the equation. So they give you a whole bunch of different options, but the ones that they ask you to graph are all lines. So make sure you're using the line tool. And then if we want to graph the equation x equals -2, show me with your arms, what does x equals -2 look like? Yep, it's going to be a straight up and down line that goes through x is -2. And so what would be the domain of that relation? Meaning, like, what are all the possible inputs? Remembering the x-axis is the input axis. Yeah. Yep. Yeah. So you're right about the range. So the domain would just be a single number, -2, because that's the only number on the x-axis that has points on the graph. Then the range, which has to do with the y-axis or the outputs, that's going to be from -infinity to infinity. And so we would say the range is -infinity to infinity. And is this a function? Nope, because essentially this input is going to an infinite number of outputs. And so this would not be a function. So pretty much all of your homework questions are something like that. The main idea is that domains are all of the possible inputs, ranges are all of the possible outputs. So if you guys want to open up your laptops and get started, I can answer questions from this assignment or from your other assignments if needed.